My name is Ken Johnson, and the presentation I am making today is TALOYOAK, Nunavut, Sewage Treatment Feasibility Study. I would like to acknowledge my co-author on this, David Brown. He's a planning engineer with the government of Nunavut. The community of TALOYOAK is located in the central portion of Nunavut, and it is located approximately 1,300 kilometers west of Iqaluit and 1,200 kilometers northeast of Yellowknife. It is a boulder glacier till material in and around the community. The active layer varies from 0.5 meter to 1 meter. There's very limited vegetation in the area, and the temperatures range from a July mean high of 12 degrees and a January mean high of minus 30 degrees. The precipitation in the area consists of 200 millimeters of snow and rain, which classifies the area as a desert. In replacing the existing sewage treatment system, the design horizon is 20 years, and this will serve from a current population of 1,030 to a 2040 population of 1,410. The sewage generation rate for this community, it is trucked services, is approximately 125 liters per capita per day. So based upon a 2040 population of 1,410, the annual sewage generation is estimated to be 65,000 cubic meters. The current sewage treatment system is a series of non-engineered ponds approximately 2.5 kilometers west of the community. In considering processes for treating or improving the sewage treatment in TALOYOAK, generally speaking, mechanical systems are not used in Nunavut. The picture on the upper right-hand side is the wastewater treatment plant, mechanical wastewater treatment plant in Iqaluit, which is one of only 4 mechanical systems. And generally speaking, mechanical systems have technical issues and cost issues. It has been pointed out that those systems that are technically simple and engineered for sufficient capacity tend to perform well, although it can be said that the lagoon systems are ultimately at the mercy of the natural environment, which of course is extreme in the far north. Mechanical systems do offer the opportunity to reduce the influence of the natural environment. However, a multitude of other factors affect the design, construction, operation, and maintenance of mechanical systems. In replacing or upgrading the sewage treatment system in TALOYOAK, 6 potential treatment facility sites were located, as shown in the figure on the upper right-hand side. These 5 new sites were identified in consultation with the community, and they were investigated. Sites 1, 2, and 5 were screened from further consideration for a variety of reasons, such as the proximity to a potential wetland to provide supplementary treatment, or other issues associated with the community use. In the site screening, final site screening, there were 2 sites, a Site 3 and a Site 4. Site 3, shown on the figure on the right, is approximately 3 kilometers from the community and 700 meters from the runway. The development of this site would include a single-cell vehicle access to a truck turnaround point. The issues with this site is very clear on the diagram, is that this area has a drainage course which bisects the project site, and the issue with this is that generally drainage courses have very unstable material, and in fact ice-rich material that would require considerable excavation and replacement. And even if this were accomplished, is that generally speaking the soils around a drainage course would remain unstable. Site 4 was also investigated and ultimately selected as the site to build the new lagoon system, and this site is located immediately adjacent to the existing lagoon, and would require the construction of a new engineered single cell and access road. The predominant advantage of this site is that it is very well drained and there's no evidence of contained moistures. So from the photo on the upper right-hand side, you can see that the material appears to be quite granular in nature, and this is confirmed with the boreholes and the test pits shown as a typical one on the lower right-hand side, where you've got the overlaying of the organics with sand and cobbles underneath, and then ultimately bedrock, providing a very thaw-stable material so that the site would not be subject to the ground movement that would have been expected at the site number 3. The lagoon treatment, as previously said, is going to be a single-cell facultative lagoon that will provide both physical and biological processes. The physical processes of sedimentation will remove BOD and suspended solids through settling. However, as previously mentioned, with the cold winter temperatures, that for the majority of the year, the only physical processes will be available for treatment. However, during the limited summer season, as shown in the figure on the upper right-hand side, is you get a very active biological activity within the cell that through sunlight and bacterial action, is you get some fairly significant removal of BOD as well as suspended solids, and the typical removal rates can be 35 to 65% of BOD and suspended solids, which provide effluent quality in the range of BOD of 25 to 180 milligrams per liter and total suspended solids ranging from 25 to 115 milligrams per liter from this single cell lagoon. As good as the performance from a single cell lagoon can be during the limited summer treatment season, is that supplementary treatment is necessary, and natural wetland systems have been the primary process that has been applied to lagoon systems in the Canadian Arctic. A significant number of Nunavut communities make use of wetland systems that for supplemental treatment. In the case of Taloyoak, an ecological assessment of an existing wetland was conducted and noted that the wetland is achieving some improvement in the quality of the existing sewage discharge. However, it noted that the wetland improvements would be necessary for upgrading the system. The wetland performance in this situation, treatment from this system, could be maximized by the use of berm structures to disperse the flow and reduce the channelization. The anticipated performance of the wetlands is expected to be with a TSS of less than 15 milligrams per liter and a CBOD of less than 40 milligrams per liter, along with an ammonia of less than 25 milligrams per liter. The photo on the lower right shows the anticipated performance with the red dot in comparison to an accumulated database of performance of wetland systems across North America. A lagoon conceptual design was completed, and the configuration was a lined earth structure 260 meters long and 160 meters wide, operating with a freeboard of 1 meter. The berm structures have recommended slopes of 3.5 to 1 on the exterior and 3 to 1 on the interior. And as mentioned, that the lagoon will have a synthetic liner. The general operating depth of the lagoon would be 2 meters, with an additional 1 meter below this 2 meters as a sludge accumulation zone. The discharge from the system is planned to have a fuel-driven pump that pumps over the berm into the existing wetland treatment system. Additional design considerations that were included in the project were a bird hazard study, given the proximity to the existing airfield. Overall, the lagoon project is expected to have a low bird hazard to aircraft, as well an aggregate study was completed just to make sure that there was sufficient earth materials to build the structure, because generally communities in and around Nunavut have a scarcity of granular material. As well, a wind and snow assessment was completed and concluded that the Site 4 was the best option for minimizing snow drifting issues. Conclusions and recommendations. So there were six candidate sites, and those were screened to sites 3 and 4. The lagoon and wetland treatment system is anticipated that it will provide effluent quality requirements to meet the regulatory standards. The use of a retention lagoon system with 10 to 12 months of retention is the most appropriate solution for TALOYOAK, with a pumped decanting system, and the minimum volume of the system is 65,000 cubic meters. My name is Ken Johnson. I am a senior planner and engineer specializing in planning and engineering for small communities, and in particular remote and cold region locations. EXP Services is a multidisciplinary engineering firm with 3,500 employees across North America.